we're busy with the sequence status. Now we are still with the WPLSoft Delta programming software. We want to do. We've looked at the basics. Last we looked at start Delta. It was the fourth reverse start Delta, and then I said we're going to look at sequence status. Welcome back. If you're joining us for the first time, please join us through subscribing, and then also please hit the like button if you like what we're giving to you, and tell us on the comment section where you are watching us from. Very important. Now let's get right into it. We want to do sequence status. Let's look at the first sequence that we want to look at. Is going to be I don't know, is this the one? Yes, that's the one. Now it says here, oh, this is a previous scenario. Let's create a new project and let's name it sequence status, and then we are using the SS2. So let's select the SS2, and then the comport is fine, it's default, and then we come and say, all right, sequence 1 Delta PLC WPLSoft. Let's call this sequence 1. All right, and then what does the sequence say? I'm gonna read it out because typing it is gonna take me forever. So I'm going to read this out. It says there, let's expand this. Sequence 1 says, and be very careful. When it comes to sequences, just like your learner's test for the driving and every other test, you must read to understand. You must read for complete understanding. Press start button and motor 1 runs immediately. Only after 10 seconds, motor 2 can start. After a further 10 seconds, motor 1 stops. That says after 20 seconds. There is going to be controversy on how you answer this because some people would have interpreted it different. I'm going to answer this in 2 ways. I'm going to answer this in the right way, in the correct way. Then I'm going to answer it in its possible misinterpretation. I know this should have been written different. I know what they want to say here, but we are going to answer it as is, and then we are going to see what I think they intended to say there. I don't think they really wanted to say that, because the way they said it's ridiculous. But we're going to do it anyway. Then I'll show you why it's ridiculous. Then I'm going to answer it the way I feel they intended to ask this. All right. So then after a further 10 seconds, motor 1 stops. A stop button, an emergency stop, or overload should cut the circuit immediately. Now we have press the start button. Motor. There's 2 motors here. Okay. Only after 10 seconds, motor 2 can start, meaning that there's a different start here. Okay. It doesn't say after 10 seconds, motor 2 will start, which makes it an automatic move. It says it can start, meaning that someone else will start it. Saying can, the word can is very crucial there. Understanding the part can is very crucial there. But if it says only after 10 seconds, motor 2 starts, then it would have been an automatic move. It would have just required a timer. After 10 seconds, the other one kicks in. But here it says only after 10 seconds, motor 2 can start. All right. After 10 seconds, motor 1 stops. But motor 1 can be stopped by us. But if we don't stop it, after 10 seconds, motor 1 should stop. Okay. After a further 10 seconds, a stop button, an emergency stop, or overload should cut the circuit immediately. It is not okay. That final line is not okay. It suggests 1 stop button. It suggests 1 stop button for both motors. Different starts, but 1 stop button. Okay, so I will do it like that. I will follow that part, even though I'm not happy. Each motor should be independently stopped, independently started according to this, and then independently stopped. But here it says stop button, so we are going to go with the text, and we are going to use 1 stop button. All right, a stop button, emergency stop. So we are going to use 1 emergency stop. However, overload should cut the circuit immediately. I don't agree with that part. I cannot even do that part, because if you're saying an overload, this is two different motors. It is illegal. It is electrically illegal to actually use one image and stop. No, what am I saying? To use one overload for two different motors. One, it can be maybe by design or coincidence that the two motors have what? Have similar characteristic currents, all right? The running currents. Now, what are you going to set the overload to? Are you going to set the overload to the sum of the two individual currents of the motors? Which would mean that if one motor is running and it is there's an overcurrent situation, the overload won't trip, because the motor has one. The two motors have one overload, and it has been set to the sum of the two. It is a risky situation that can destroy the motor. That small time doesn't matter how small it is, but if an overload has to be set to a specific current for the motor, so you cannot have one overload for two motors. Impossible. So that one I will not accept. I will accept with reservation one stop pattern. I will accept it's possible to have one image and stop for the two. Yes, so I'll accept it's possible for that. So one image and stop, one stop, I will take it, but I will not accept one overload. Overload has to be different, because the two motors might have the same current, might have different currents. So I will not accept one overload. And then so let's go with this. Now we are going to say we have one image and stop. So what I'm going to do is I'm going to load an image and stop here. It's a normally closed, even though in reality it's going to be what? Remember, image and stop is a normally closed already. So in reality it's going to be normally open, but for purposes of simulation here and for theory purposes, we're going to keep it as normally closed. All right, that will be, let's say, x0. That there, or let's name it, it is there. Image and stop for both, because we said we're going to use one image and stop, which is possible. That one's not an issue. So image and stop. All right, and then we are going to have one. Okay, we're going to have another normally closed. We'll call it x1, which we'll call it the stop. We said we are going to accept one stop for both, so we're going to say that is a stop, one stop for both. All right, so if you hit the stop at whatever point, the circuit dies, which is fine, it's acceptable. Now, however, I will not accept one image and one I will not accept one overload, because there's two motors. So I will have overload one for the first motor. Again, overload is normally closed. Okay, that will be, I will add overload to x2 and x3. That will be overload for motor 1. Overload for motor 1, I'll just call it overload 1. And then I will have a second overload. Overload, what do I do? Overload 2 for the other motor. What do I do? Overload normally closed. We are going to call it x3, and I meant to write that part here. Overload 2. All right. Yes, I left space there because I know I'm going to start and stop, so start will need me to latch, so I left that space for latching. So now I'm going to say, okay, now I'm going to start. So I've got two different starts. The one start is it's x4, okay, and I'll call that start 1 for the first motor. Okay, keep doing that, and then I'm gonna have start 2, which will be x5. I must not forget that I only have up to x7, right? Because remember, I'm using the SS2, the what call this, the PS02, the DVP PS02. It has inputs x0 up to x7, which is 8 inputs. So I already used 2, 4, 5. This is the 6th one, so I've got 2, 4, 2, 4. This is the sixth one. Yes, I've got 8 of them. Alright, yeah, so that's fine. So I forgot to say this is the second start. So this is start 2. Start 2. Okay. And then now when we start, we are going to latch. Remember, it must keep itself on, so I must latch. So I must remember I'm going to have latches here. The first one here starts motor 1, so I'm going to say out, and I'm going to say Y0, and that's motor 1, so I'm going to name it motor 1, motor 1. Okay, then I'm going to say I'm going to want to latch this. Okay, and this is going to be Y0. Alright, so I've latched that. I also want to latch start here. I'm going to start motor 2. That will be Y1, and that is motor 2. So we're going to name it motor 2, and then we are going to say what I do. I wanted to say out, not out, motor 2. Okay, then here we latch LD, and then you say Y1, and you've latched that one. Yes. So before we do this, now we need to understand something. When we start motor 1, we are going to also set on a timer, and that timer is TMR T0, which is a resolution of 100 milliseconds. Therefore this will be K100 to make it 100 times 100 for 10 seconds, which is a 10,000 milliseconds, which is 10 seconds. So this will be that. But then now what happened here, I don't like it like this. Not that it's an issue, I just don't like it like that. Ah man, okay, it's fine. Now also I'm going to say, okay, but this one here, that timer, when it times out, it must enable this start. So we must come and say load T0 there and say, okay, by the way, we set it to 10 seconds, just as a reminder of the delay time. Okay, so we say now when this times out, it's gonna close that one there, enabling our second start. And when the motor runs, it must run. It doesn't say it will stop at any time, so we'll stop it with a stop. All right, so what will then happen is that we need to just, so we close this in because the timer will kick in. So whatever happens with the first time here, whatever happens with Y0, it's going to also affect, if this loses power, this will also lose power. We don't want that to make this stop as well. All right, so what will then happen is that they say okay, what happens here is two things happen here. When this time, after a further 10 seconds, okay, so T0 here must actually start a second timer. So I have two ways of doing this. I could have made T0, in fact I've got no other way. I have to come here and say, oh, what I do, okay, I wanted to go down. I must come here and say T0, load T0. What I want this to do now is I want it to enable another timer, because it says after a further 10 seconds. So I'm going to have timer 2 here, TMR T1, which is 10 seconds, which is another K100, 100 times 100 milliseconds. The resolution there is going to give us 10 seconds. So after a further 10 seconds, we are the first motor, because after a further 10 seconds, so which basically means after 20 seconds, this one here must come and stop. So I will come and do here and say LDI, which is the T1. Normally close for T1, we'll then say another 10 seconds there. 10 seconds there. This first one must stop. The first motor must stop. Literally means after 20 seconds. This is one way. This is what I said was, I am going to write this out the way it is. Then I'm going to do it the way that I think they meant it to say. Because the way it is now, it does not matter whether I start the other one or not. It's irrelevant whether I start the other one or not. If I start the other one, because again, let me ask this. The way the statement is written, what happens if I try to start motor 2 after 21 seconds? From the strict language of what we read, let's read it again. Press start button, motor 1 runs immediately. Only after 10 seconds, motor 2 can start. So it means we can start motor 2. It doesn't say it will start, it says can start. So we are able to start it after 10 seconds. So we can start it after 10 seconds. This will energize. Now we can energize that part and the power will go through. After 10 seconds, motor 2 can start. That's fine. Now, the statement that I'm interested in now is after a further 10 seconds. So only after 10 seconds, motor 2 can start. But it says after a further 10 seconds. Further from what? Further from the previous scenario, which is the 10 seconds. So meaning 10 seconds after the first 10 seconds. That's what it means. So it means more after 20 seconds. 10 seconds plus 10 seconds is 20 seconds. 10 seconds after the first 10 seconds will give us 20 seconds. I don't know why I see my picture is freezing there. I've got no idea what's going on, but my picture is freezing all over the place. Really worried. I don't understand what's going on. But anyway, what's important is that you've got the I hope the sound is not also freezing. So now, if you go on, it says after a further 10 seconds, motor 1 stops, meaning after 20 seconds. That's what it strictly means. If we go down to the text basically says that. Now, a stop button, which you've dealt with, emergency stop, which you've dealt with, or overload. I refuse there. I said overload. I changed that by force because I will not allow a scenario that is illegal to persist. Okay, so each motor must have its own overload, so I will not accept one overload. All right, so if you are forced, if you say okay, it's a theory situation, let's not worry about the practical, then we would have put our what, would have not had that second overload there, would have simply come and brought that line down from there. Okay, we will brought a line there and not have had this other overload. But I don't want to do something that I know is not acceptable. Okay, that is, I cannot accept this is criminally this is procedurally wrong. You cannot, I mean, you have to think about safety, you have to think about all the laws. Okay, you cannot allow a scenario that actually breaches the law. Right, just like we can't make an example about the rape of kids, we will not allow a scenario that is going to be very dangerous here. It's not it's not permissible to have one overload for 2 motors. All right, the rest is permissible, so we allowed it, but it was not permissible to have one overload for 2 motors. So then now, this text here, what does it mean? What does it mean? What you understand it to mean happens if I try to stop, if I try to start the second motor after 20 seconds. That is another difference that you need to deal with here. As we've programmed now, you cannot start this motor after 21 seconds. But the language says I should be able to start this motor after 21 seconds, the second motor, as long as the other motor has started and run is 10 seconds. Whether it's a further 10 seconds, there's no restriction as to say whether after further 10 seconds this one has stopped, the other one cannot start. It doesn't say that. So it means maybe after 21 seconds I should still be able to what? To start my motor. So I'll start with a scenario where after 21 seconds you cannot start this motor. Alright, let's start with that. Let's simulate. Now I will come in. I won't care about all this for now. I won't care about any warnings for now. I'll just care about does my sequence do what we said. Okay, let's see. Can I start motor 1? Set on. No, I cannot start motor 1. Motor 1 is not responding. There you see, motor 1 is not responding. Oh, I mean motor 2. Can I start motor 2? Sorry, I meant to say, can I start motor 2? No, motor 2 is not responding. So, why? Because I have not started motor 1 and I haven't had my 10 seconds. All right, so now I come and say, I'll leave this start on because I've got very little time, so I'll leave this start on. Now I start motor 1. As you can see, motor 1 is running, but motor 2 is not. All right, motor 2 is not. It's waiting for the 10 seconds. Now let's suppose I did this after 10 seconds. I'll wait for 100. There I click it, and there you can see it's running there. All right, now I come and disengage, but it's counting. The timer is counting. The second timer is counting. You will see now that one will stop. Y0 will stop. Y0 is stopped. Okay, Y0 is stopped. So as you can see, our sequence works in a way that now after that, can I start this motor? Set on. I can't. So I believe that this is what he meant. All right. I believe that this is what he meant to say. Whoever said our question meant to say, he or she. All right. With all respect to probably being a lady. So so now it means I can only stop this motor if I hit the stop. All right. So now I believe that this is what he meant, except I don't believe that set off. I don't believe that he meant for this sequence to work this way. I believe that he meant to say motor 2 can be. Let's first look at the other scenario. The other scenario is once the motor 1 is worked, okay, it does not matter. It should not matter whether once motor 1 is worked, it should not matter whether. Let me come. I don't know whether I'm going to be able to explain this nicely. Let me switch this off. The other possibility that I was trying to explain is, let's suppose we wanted, as long as the other motor is done, has been started and is after 10 seconds, whether it stops or not after the further 10 seconds, can you still be able to start the other one? I think if that was the option that they wanted, we would have seen that maybe this T0. Let me rather come here and say, remove this. Let's change this to T0. I think you've seen the first one. You can still go back and check it. Let's change this to T0. Okay. And then let's remove this one here. I could even leave it. It doesn't really matter. It's a redundant second. It's just like if there's 2 of them, it just means 1. I mean, it's really an end of the same item is just basically like a buffer. It's just like 1. But just to be safe, I'll remove that. So I can close this. Now these 10 seconds here, I won't let it start. I'll have my Y1 come here. I'll have my Y1 come here. Okay. What I've done there is I want this to be an internal relay. Okay. And I want the internal relay to latch itself. I want to show you. Let me finish what I'm doing. Delete the vertical line and delete this one. What I want to do here is I want to latch. I want to change that scenario to something. Let's say M0. Okay. So after this, I want this M0 now to come here and start LD M0. Now this scenario here is after 10 seconds, this M0 here is going to remain. Once this is counted 10 seconds, this will remain on, and now you can start what? You can start you can have your start. Where's our start? Just come there and say I want to normally open. It's X what? X3. Let me just cancel and see which X's have I used. Let me go back to my program and see X4. Okay, I need X5 for my start. X5. Okay, now I want this to start my motor 2. So what does it mean? After this is counted out, now I can start my motor 2, and my motor 2 can still be, as long as the first motor at this 10 seconds, this one can start anytime after that. So this is the two different scenarios. The one scenario is after the second motor is stopped, you can't start even if this first motor is run. But the second scenario now is independent. If I, as long as motor 1 has had its 10 seconds in the what? As that is its chance of 10 seconds, then the other motor can start any time after that. Whether it's 50 seconds, as long as you initially hit the what? The start for the first motor. So let's just add a thing there. Okay, before I do that, let me add a rung here. Insert a row, and then now I can come and say, remember the start will be released, so want to latch until we stop the motor. Let's say now this is Y1. So this way, if I say run now and I simulate there, yes, I don't care about the no. What they do? I didn't read. I just clicked that without reading it. I want to see what it was saying. I wanted to say yes. Oh, okay. I don't get that message again. Now let's see. If I hit the start, set on. Oh, it's on stop mode. Okay, it's on stop mode. I did not say yes. Now if I hit the start, watch this. The first motor is running, the timer is counting. As you can see, it's counting there. Look at my cursor. At 100, it's gonna kick in there. This is holding. So even if I can start now, or I may not start now. If I want to start now, motor 1 will run after the 10 seconds. But if I don't, you can see that this one will stop. It has stopped. But because I had that TO was energized, that timer was energized, I can start this any other time after that. So I can still start my second motor. So the two scenarios, it depends. Now when you ask students, I think it's very important to ask situations that are, to ask sequences that are not going to be confusing. So a student could have answered it, could have understood it the first way. A student could understand it this second way, and they'll still both be right, because it does start after 10 seconds. It says it can be started after 10 seconds, so anytime after 10 seconds. So if the first scenario, my problem with it is there was no restriction as to the stopping of the second motor was not written explicitly to imply any implication on the stopping of the first motor was not written to explicitly imply any effect on the second motor. So it still started, and it's still after 10 seconds, even after 21 seconds, still after 10 seconds. So one could easily say, I should still be able to start my motor. So I think this is a more correct way of answering that question, because it is after 10 seconds, even if the other motor is stopped, it is still after 10 seconds, and I'm still able to start my second motor. So I don't know if that argument makes sense, but it doesn't say anything from here. It doesn't say anything about what happens about motor 1 or whatever, but the conditions we were asked are all satisfied, and therefore we are happy. Because if you are going to argue with me that this is wrong, then tell me what is in 27 seconds. 27 seconds still after 10 seconds. So 27 seconds after motor 1 started, I must be able, according to this statement here, I must be able to start my motor 3. But at that point, according to that statement again, motor 1 is stopped. So what I'm thinking, this is not how this was intended. This confusion was not supposed to be there. So I think the writing introduced this confusion. What I think was meant to happen here was the statement should rather have said motor 1 should stop 10 seconds. That's further, after a further 10 seconds. I think it meant to say 10 seconds after starting motor 2, motor 1 should stop. If that had been said, it would have made life very easy. Okay, if that had been said, you start motor 1, it does not matter how long motor 1 runs for. As long as it's after 10 seconds, it could be after 100 seconds, but still after 10 seconds, you could start motor 2. If you then start motor 2, 10 seconds later, motor 1 will stop. So, but that language was written, the writing was a little bit not so great, because in the sense that it opens up these arguments. But had it been said that 10 seconds after starting motor 2, motor 1 will stop, then those two scenarios fall away. You only have one scenario now, which is then going to say, after we then delete everything here. We then delete everything here and say, you are too ambiguous. You are too open to interpretation, too much interpretation. What we'll then do is say, okay, this here will be our second motor. Out Y1, okay, and then we'll say this is our second motor, and this here is also the way we've done it before. This is our start, okay, and then here we close the two in, and then we say you will start a second timer, T1, that will be TMR T1, and then that will be K100 for another 10 seconds, and then this way, then T1 will come and stop the run there, which is fine, and then we wouldn't have this. Now that all those confusions fall away. So this way would eliminate the confusion. Why I feel that it should have been done this way, because the other confusions then fall away. What they do, I wanted to say delete the vertical line. Okay, now I want to delete this whole row. I'm deleting everything else after this. As you can see, it's a nice and neat and very short program now, and it solves a serious dilemma that we had. The way it was, if it was meant the way it was written, it would have been very confusing, because those two options were now going to be options. Those two options were going to be options. Now, this way there's no option. If they said no, after a further 10 seconds, then the other motor should stop. Then, after 10 seconds after motor 2 starts, motor 1 should stop. Then this would be perfect, because this is what would happen. It wouldn't matter how long we run motor 1 for. Okay, it wouldn't matter how long you run motor 1 for. Let's first run this. It wouldn't matter how long you run the first one for. Set on, I wouldn't even worry. It wouldn't matter, because this counter counts out and waits. Now you see the green is going to come and set there. Okay, so we are set to T0 is waiting. So it doesn't matter if motor 1 runs for another 2 years. Okay, but then as long as after 10 seconds, anytime after 10 seconds, I can now come and say start. And when I do that, 10 seconds later, motor 1 should stop. If the languages say that, this would have been as easy as it. Oh, what did I do? Oh no, the latching here is wrong. We didn't change the latch. So here the latching is not correct. We forgot to modify the latch part here. Okay. So this here is actually Y1, right? Yes. Y1. Alright. So we didn't latch correctly, so let's go and try again. So now we can say start or run first. Then now you start, and then it does not matter how long this runs for. It runs for as long, but I cannot start now because T0 is not enabled. Now it's enabled, I can start the second one. When I start the second one, set on. Now you see it works fine. So the two motors are going to run together for 10 seconds. Alright, and then motor 1 will stop. You can see that will break after 10 seconds, almost there, breaks, and motor 1 is stopped, and motor 2 runs solo. So I believe this is what they intended to ask. However, the question shouldn't have said after a further 10 seconds. It should have said 10 seconds after motor 2 has started. Motor 1 should stop. That one would have cleared a whole of a lot of confusions. So I hope that this was helpful. This is our first sequence. We are going to look at other sequences at a later stage. Hope this was nice enough for you to like. So if it was, please do like. Join the family if it was your first time with us and you are happy to be part of us. And then please comment and tell us again where you are. Thank you so much, and I hope that was as much fun for you as it was for me.